Well, hi, good morning. Thanks so much for joining me here in my shop on October 14th. Yes, sirree. Okay, so things have changed now with this radio. I've kind of gotten across a number of repair bridges, kind of fixing the defective capacitor, just about losing everything while I did it, fixing the string here. Those two issues really stood in the way of doing much else with this radio. So now the mechanical stuff is out of the way. And the tube testing is out of the way. I'm pretty sure I have a reasonably functional set of tubes in the radio. So if the radio's not performing, it's fairly certain it's not because of the tubes, which is where I wanted to get to. So what's next on the list of problems here? Well, weak FM is the one that's really standing out. This radio only receives 3 bands. Receives FM, regular AM, and long wave. Well, long wave is useless, for sure. Here in North America, anyway. So really just have an AM, FM radio here. AM seems to be working pretty good. FM, no. Volume is low. So what's left to do in this radio is some more checking, some voltage checking. I'm going to do that next. And then get to work on the component trouble that might be in here. Most likely some capacitors. What is causing the weak FM is a good question. I don't have really an answer for it, except to say it's not the vacuum tubes. It could be the alignment of the various adjustments that are in here, or it could be a component failure. So we're going to kind of go down the component failure road here in hopes of finding such a thing. It can also be dilapidation, general dilapidation. It can be a number of components that are weak. In some, they end up, causing the FM to be low, when any particular one of them will not show that it's the cause of the problem. So, I did take a look at the capacitors very early on. They appear to be, most of them appear to be pretty good, in pretty good shape. But that, how they look and how they are can be two different things. Now what I'm looking at here is, how can I flip this radio over? Can I flip it right over? It's going to be sitting mostly on this. I don't think that's too good an idea. It would be sitting on this. It would be sitting on this. But this is just a little weak here to do that. So I flip it right over, I think I'll be in some trouble. Up on its end, you can flip it up on its end. It's got this heavy transformer right at the end here. It would be sitting right on the transformer, which is not so good. I'd have to shim or put blocks in to kind of balance it out. That's looks really unstable to me. Flipping it up on this end with the transformer up in the air is just really unstable right from the start. And you've got this and this. It's really no good way. I guess flipping it right on its back. If we flip it on its back, it's going to mostly, because of this transformer, it's going to hang over. It's going to push on this, which is also not very good. No good options here. Best thing I could get is it flipped right over, I think. I could put a block on here. Take the strain off of this. Let me just look here. So this and this are pretty much the same height. So if I just get a block in here, I could even do something on top of this. This is a little loose. Sometimes a looseness like that indicates the part's been replaced and the new part is loose. But I don't think that's the case here, because I see this tape. It's the same tape that was applied to hold the tubes down, so I'm pretty sure this is all original. The thing I could do is I could slip this light off. This is awfully low, and then I could put a block in here, a wooden block, big enough, like this. So it's not quite thick enough, but it's pretty close. It's probably close enough, because it's going to be on three legs, so it'll work. I think that'll work. I have this wire over the top, but I don't think that's a big deal, actually. And the light over here, that's not a problem. Okay, that's the plan. Now how do you flip it over without dropping it? And go this way. It's pretty good on the wrists. And go this way, that's pretty tough. Come forward. Block will fall out. Block's probably going to fall out anyway. Okay, let's just try it like this. We'll see what we get. There we go. It's not as heavy as it looks. Okay, what did we end up with here? Let me just look underneath. We're sitting on the block. It's a little low. In fact, it's going to be the glass here that's going to hold it up. I think that's okay. Another block in here, and a bigger block. There. You know what? That's very good. A little bit tippy, but I don't think that's a problem. Okay. Success has been reached here. Very good. Now, I don't want to do the voltage testing, so I'm looking in. There are a number of definitely questionable capacitors. The owner reminded me in an email that I spotted something that looked blowed up in here early on, which I'd forgotten about. I was probably talking about the ends coming out of some of these capacitors in here at the time. I don't see anything blowed up right now, but yeah, some look really good. Oh, there's one down here with its guts kind of coming out. Black tarry material leaking out of the end of it, or oozing, that'd be the word, oozing out of the end of it. Okay, so quick inspection, doesn't show anything too dramatic here. I think I'm just going to boost my light a little bit in the shop. That's a little better. So larger capacitor down under here, it looks good. So if I were to do the general capacitor replacement and target, say, all these kind here, 1, 2, not too many, 2, 3, 4, 5 or so. If I were to do the general thing and get rid of all of them, there's one here that looks a little suspicious too, this blue one. The way capacitors look doesn't usually help too much in what condition they're in. I mean, obviously if they look beat up, they probably are. This one over here, which I have a little trouble seeing it there. It's this one with the guts coming out. It also has a lot of dust adhering to it and sticking out, like little dusty fingers sticking all over it. And that indicates this has got high voltage duty. It's got high voltage on it. It just gives you an idea where it is in the scheme of things. Okay, so the other thing I would really like to do is test the output voltage of the power supply and then what voltages are reaching these tubes. And I'm going to stop and take a look at the schematic and see if it doesn't give me some voltages that I can compare to. Now just get out my voltmeter and we'll just check along all these tubes and see that they have their correct voltages. It's possible a lack of voltage or incorrect voltage is what's causing the weak FM, and we noticed this odd effect where as the radio was warming up and voltages were coming up into place, there was a moment where the radio seemed to work better briefly. So that's a hint of some kind of voltage problem. Okay, I'm going to stop for a bit and we'll get ready to do some voltage testing. Okay, here's the schematic. It's a little bit big for the screen here. Let's start down with the power supply and see what we can find out. So here's the power supply. It's a single high voltage output, and this is for running the heaters on the tubes. So it's Pretty simple stuff. This comes out, comes to a dual capacitor, 250s, 50 microfarads. Side goes up, comes into the output transformer. Part of it comes down here. This is a weird way of showing a resistor, but notice it's a 3-watt resistor. So somewhere in there is a pretty high wattage resistor. Here's another one over here. We won't worry about this just now. We'll stick with this. The high voltage then comes down through here. Another capacitor to filter it further, so you have an even higher filtered DC available, and it's spread through the radio on this line, mostly going to plates and screens, I would think. So this goes to a screen grid, and this goes through these transformers to the plate. Likewise, this one comes up here. Not sure what those dots are. What are these dots? I can't say I've seen that before. We got dots, we got little tails coming out here. What do they mean by all this? Mean something. Okay. But in any case, the DC comes up, goes through some fairly large resistors. Usually the plate of the triout here is at a relatively low B+ voltage. The B+ voltage coming out of here is marked over here. In the box, you can see two amounts, 270 and 265. Looks like a small increase in the current drain when you're on FM. How do I know it's FM? Because over here is a hint, where in the solid box is the medium wave voltages, and in the dotted dash box is the FM voltages, slightly different. Well, I'm not going to bother guessing at why that is, but as you flip the switch, things are a little different in the radio as you go from AM to FM. So there's a voltage we can look for, 270, probably close to 270 here, maybe slightly reduced. Do they write the voltages anywhere else? That's what I'm looking for now. Looking different places where they would tend to write a voltage, like out here. They're in a square box. I don't see any square boxes. Oh, look at this. Okay, this changes the picture. Oh, they've made it somewhat easy here. So they're showing the tubes. Right, they're almost certainly showing them as viewed from the base, like I'm looking at them now, with the radio upside down. Does it say that somewhere? But they're showing the pins as they're laid out in the tube. Pretty sure. I'm not positive. So this is for a shield. This is typically pin 1 as shown, so I'm pretty sure this is laid out. What shield is this they're talking about? There's no shield on those tubes. There's a shield on the FM tube. That's this one. The shield isn't in any way connected to any of these terminals. Well, that one's an S. You've got S on it and it doesn't seem to go anywhere, so I don't know what that means. Okay, we have tube voltages. This is perfect. This is exactly what I want. I'm going to stop and rearrange my video screens here so to make this as easy as possible for me to do and for you to watch. Okay, very good. I'm going to be using this meter. And the first issue is what to do with the ground lead from the voltmeter. On the schematic, there are many connections shown. Well, you can see them here because the schematic's on the screen. There are many connections of this sort. See this little dash here, which is a style for indicating a ground. I put my air quotes up. Ground. I hate that word. That word's a bad word. So these are actually connections right to the chassis. Up here is an interesting. Looks like a real ground symbol right beside what looks like an antenna signal or symbol, and if you follow these wires over, sure enough it's involved with the antenna system. So this symbol here is really referring to a outdoor ground of some sort, I would say. Something that's actually connected to the dirt around your house. But these all mean to the chassis. The voltage readings, so often there's a note on these schematics about where you take the voltage readings to or from. I can't sort this out. Probably in here it says something like that. I don't know. Incidentally, here's the IF frequencies, which will be important later on down the road. 10.7 for the FM side and 468, an unusual number, for the AM IF frequency. So something worth noting when you can. Okay, connect up the ground. So the ground can go on the chassis anywhere where it won't get in trouble. Put it there. Wire hanging up. Let's not do it there. Let's do it. Actually, there's a nice terminal right there. That's good. Okay, make sure my lead is set to DC. Now I'm going to practice a little bit before I turn the power on. That's to find out that I can't reach something, or without having the power on. So first thing I would want to test is the output from the power supply, and that's going to be on the back of the filter here. See, wires come out, and they go to the terminal strip. That's nice. And then there's a spring right here. So I just go across here. This one's red. This is probably the high voltage one. This is probably the one we're going to read the voltage on. What was it? What was that number? What was that number? What was that number? And the number was... Oops, a little bit further. 270, 265, somewhere in that range. 270, 265. That's what we'd be looking for. And on these tubes, this first tube is the FM tube. We cannot really get access to the terminal side of the socket here for this tube. Unfortunately, it's just out of reach. So we're going to go through the next tube and we'll check that out. So this is 1 and 2. This is the magic I tube. We're not going to worry about that just yet. Okay, so it looks like 2 EF89s. I'm going to test those two tubes. EF89s are this tube and this tube. It's a little shaky. I'm going to just make that just a wee bit more stable here. Just dig through my selection of pieces of wood. That's not going to work. I just don't want it shaking around while I've got a probe in there. I'm bound to lean on it a little bit. Somewhere I've got something I can stick under there. Okay, that's good. And we got things just stabilized a little bit better. Okay. DC plus, 500 volt scale, reading over here. Then these two tubes, diagrams up on the screen. I can make it a little bit bigger, I think. Yeah, that's good like that. Here we go. Okay, any reason not to turn the power on? No. Okay. Of course, I don't think the switch is on. Now, which switch is which up here? So this is the off-on switch. It's FM, AM, and long wave. So we're going to go with the AM switch here. Can you operate a tube upside down? I think most tubes would not really know much of the difference between upside down this way or that way, but sometimes this way is a problem. Not so much for the more modern tubes like you find in here, but you get much older tubes. Maybe not this one, but some tubes, really old, let's go back here, like older tube like this, may not be operable on its side. Or if you have it on its side, it may become very sensitive to any kind of accelerations in the radio. Did this radio come on? The lights are on. I need a little volume here. Okay, there's no antenna, so the volume needs to be turned up a fair bit. Of course, I don't have it on full voltage. I got to do this on full voltage here. And we'll just check. 110, that's not full. Probably want this a little higher. 10. Just turn it up a little bit. 124, yikes. 116, that's good. That's good enough. Now, ready on the first reading. I'm going to try not to get in front of the meter. Yeah, and where's it supposed to come? 270, 500 volt scale, so 270 is just past the halfway mark. Just past the halfway mark. What do we get right here? Okay, so we're almost 300 there. That's good. That's fine. That means the power supply is producing what it should. Now we want to find out, is it making it all the way to the tubes? So we'll look at the EF, either one of those diagrams, basically. There's only really two electrodes I want to check, and that's the screen, which I'll point to here. This would be the screen, the one in the middle, and the plate. This guy, it should be 0, and this guy is the grid. We're going to leave it alone right now. And we're just going to check the two high voltages. So looking at the diagram, it would be it would be pin number 1, 2, 3, 4, 5, 6, pin 7, and pin 8. Is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9. And 7 and 8. Okay, 7 and 8. Look down in here. Count backwards. 9, 8, 7. Okay, so I'm going to do 7. 7 was a plate. Oh, scare yourself. Can you see the meter? Something doesn't smell good. Something not smelling very good. So 240. That would sound like a pretty good plate voltage. Now we'll go to the next pin over. That's this one right here. Oh, that's very low. That's very low. It's a big 50K resistor right here, I think. So the sniff test says there's something heating up over here. A little more than might be desirable. Not really detect it with my hand. What we might do here, well, let's get around with this voltage thing. I'm almost done it. Okay, so let's compare it to this other tube. Looking for the same pins. Is the tube in the same way? Close, but not quite. Yeah, wow. It could be I've just turned the radio over and the heat from the tubes, the hot air, is traveling up in a different way than it normally does, and it's heating up stuff, like turning your furnace on first time in the season. You get that smell of cooking dust coming out of it. Okay, concentrate. Pin number 7 would be this one. Here. Plate. Same, this is about the same as the other one. And now screen, about the same as the other one. So the screen, actual screen voltage. Okay, so we're on the 150 volt scale. Screen voltage is actually 150. Did I just see smoke go by? And over here, no, much less. The same tube. Same plate, should probably have the same screen voltage. Okay, so I'm going to find out what's getting hot here before we end up with a bit of a surprise. So I'm going to turn the radio off. I'm going to go get a little piece of gear I have, and we'll be able to sort out how hot, or what's getting hot in there. Okay, so what I've got is a thermal viewing device here. There's still some heat left in the radio, and you can see that there's there's something on the screen there. It's quite challenging to sort out what this is actually seeing because it has a very wide field of view. It sees a lot. So one thing for sure is the tubes and their tube base will heat up, and over here is the output tube, which gets particularly hot. So not surprising that there's just a general buildup of heat over here. Again, it's very tricky for me to get this on the camera and in my eye at the same time. So I've adjusted this now, so if you see red on the screen, the temperature is up around say 45, pushing 50 degrees C. That's about as hot as you want anything to get in these radios, except for the tube itself. The tube itself gets quite hot, very hot, burn you mercilessly hot. The residual heat's interesting because it's been 5 minutes or so and there's still a fair bit of heat buildup. One of the items, can you see there's something this way? That's this resistor here. So there still is some warmth in it. That's why it's showing up. There's another thing down here, and look at that, it's that capacitor. Can you see it there? Capacitors should not be getting hot unless they're heated by something external. And there seems to be, now what I can do here, I know you might not be seeing anything in the camera because I just can't manage the whole thing. What I do is I think, oh, is it this resistor that's hot? I put my finger above it and block it. Of course, I'm using my warm finger to do it. You can see my finger go by. This helps me identify the part. It's definitely this resistor. A little bit of heat in it. Okay, we're going to turn the machine back on. We're going to watch it warm up. What I'm most curious about is the capacitor down here with its guts partially leaked out. It's a little hard to see. Yeah, it's still hard to see in the camera because it's black, but the shiny part at the end here that I'm pointing at, that's black compound that has come out of the capacitor. I think it's better to keep the compound in the capacitor and have it come out. And that might more or less, see, like this one here, that might just be kind of like a seal on the end. It's not actually all the way through the capacitor. I don't know. The capacitors should not get hot on their own. I seldom have I found one like that. So here we go. Who's gonna heat up here? Now I've got the radio on restricted voltage, so it's. You can see first. You can see this resistor warming up. You can see two other components warming up. One is this, which I think is a wire wound resistor. I don't want to stick my finger in there too far. Oh, what do we got? A red over here. What's getting red? I have to kind of triangulate these things. So that little resistor there is getting red. Well, it's turning red on the camera, which means it's close to or above 50. Now this thing is interesting. It'll tell me three temperatures. It'll tell me the highest temperature on the screen, the lowest temperature on the screen, and the temperature of the plus sign, which is dead center right there. There's like a target thing. So those three things are reported here. The big white numbers are the plus sign. So if I can get the plus sign on the red thing, plus sign on the red thing, the big numbers will tell me the temperature. How come it's not red now? So what's happening is as I'm moving the camera, there are items one above the other, and as I swing the camera, it can see past the upper one. And so the lower one is the one that's generating the heat, just by swinging the camera around. I think that's what's happening. So here I can see it. What is it exactly? Could be just the base of the tube socket base. If I go straight down, I think I'm just seeing the base of the tube socket. And then it's blocked by these various structures, so it's coming and going on the screen here. Right? It's a two-dimensional camera on a three-dimensional situation. Okay, what about that capacitor? It doesn't seem to be getting hot. You see this large resistor is just starting to reach the red point. The littler one is 51, 50. Yeah, it's not enough to really be too scared. If it were 75, I'd say that's probably hotter than it's really intended. But some resistors are designed to get hot. You know. Here's another one here. One of these was smelling. Oh, look at that, 105. What am I looking at? Something is 105. Is it that resistor right there? You know what I think it is, judging by the way. I think I am looking through a hole in the chassis and seeing the glass tube down here, which is super hot. Right, and the glass tube is super hot. 150, that's normal. 100, look at almost 200 degrees. That's why you don't dare touch an output tube, because your skin will be off before you know it. So that's what's happening there. I'm seeing through holes and picking up things that are farther away. So not a concern. So if we go straight down here, you see the tube socket. See this resistor and the other one behind it. I don't think it's anything too important actually, because it's not that. I was really quite concerned about seeing the capacitor warmed up, but it's not showing up. So it must have just picked up adjacent. Let's look at the whole thing here. Just see if there isn't something else that comes leaping out of here. And I have this set so anything over 50. Close to 50 should put a red spot on. 50 being the danger zone in my opinion. Here's the another item of interest is this great big selenium rectifier here, which these things sometimes fail. You can see it's showing up on the screen there. It's not, there it is. I got in the center there. This piece here is this. You know, by hand, barely warm. It's a bit of a reality check. Okay, I don't expect to find anything up here. There is something a little warm up here. There's a large resistor right here. That's showing up warm. Seeing the tube socket here. Yeah, okay, so the reason I'm doing this is because I thought I could smell something getting too hot. Thought about the main transformer. Looking at it here. It's nothing significant whatsoever. Do a little reality check with my hand. Yeah, there's nothing going on. It takes a long time for a transformer to get hot. Anyway, if it was hot at this point, that would be bad. Okay, the concern about something overheating I don't think is a serious concern. We'll carry on. Maybe this one little resistor here is not in the best shape. We'll take a closer look at that at some point. Back to testing for voltages. Okay, the next tube along the way. Oh, wait a minute, these voltages are written right here, Jim. Come on, man, wake up. So we expect 200, no, let's read the top box. We're in the AM mode, so 229. Oh, here's 223, it's just about the same. And then the screen, 154, is 67. Yeah, I got these tubes mixed around. Who's who? This is number 1. This is number 2. Number 2 is at 67. That's roughly what we measured. Alright? So, 67. So on the 150 scale, you know, that's pretty close to 67. Now the other one had a higher voltage on it, just looking here, 154 in the AM mode. So 154 here. That should put the meter right over. Doesn't quite get there. So that's 125 instead of 154. Am I reading this right? Okay, yeah, 154. Okay, so now we're going to flip to FM and see what happens to these voltages here. FM will be here. Oh, Jimmy, come on, put the power on. That was bad. Say that was bad on all fronts. Let's just get this out again. And by now the heat is building up, so that results in higher temperatures. Capacitor's not really showing any heat in it. Hot capacitor, I think that's an unusual thing. Where'd the sound go? Did I turn the voltage up and the sound disappeared? Just give it some time now to... 89 volts, that's pretty low. You know what, it's my imagination. The sound disappeared because I flipped it to FM. That's what that was. Turn it up. Okay, so that's FM for sure. Now, we'll check the two plate voltages, which are supposed to be 229 or so. That's not quite to the middle on the plate. Not quite to the middle on the plate. And over here, not quite to the middle. That's perfect. Now we'll do the screens. Check the voltage is on the chart. Both low now, 72 and 61. 72 and 61. So that's almost straight up or a little back from straight up. Okay, that's just about where we would expect it. And the other one right here, just about where we would expect it. So voltages appear to be normal on those two tubes. The next tube to check is the detector tube here. This one's tricky. Should have a low plate voltage. Let's just take a look and see what it says. So that's this one here, EABC 80. Come around, they're just pointing to one terminal. 74 on AM, 62 on FM. Okay, we'll give that a little bit of a go. Which pin is it? It's oh good, it's the last pin, pin number 9. So pin number 9 and 150, so about straight up. Pin number 9 would be right here. Looks a little low in the meter, so the meter is telling me 50 volts. And the chart is telling me 60 or 70 volts. 60 in FM. 60 in FM. Okay, let's go to AM. Ooh, volume down. Where'd the hiss go? There was a hiss there before. Okay, no antenna, so those hisses would be reduced quite a bit from that. Now we're looking again at the plate here. I don't like to ground my hand in any way on the chassis when I'm doing this. I just keep my hands to myself. 50 again. The same kind of lower voltage. Okay. So we could look on the other side of these resistors here. See what we get. Probably a lot more. Not much more there. It's the same voltage. This guy's a little more. This is 150 volts here. If I saw a big difference between, either side of these resistors, I'd be a little more interested in that. I can smell the cooking again. The cooking
Let's start it up again. It's not the big transformer. Ooh, this is getting a little warm. It's definitely, you know, unfortunately we don't have smell-o-vision on YouTube yet, so. Okay, so looking at the rectifier first. Temperature of the rectifier is under 50. Probably still normal. Again, if it was like 80 or 90, I'd be quite worried about it. This heat is building up in here. So that resistor is about 85. The tube base, let's just tricky to aim this thing. Somewhere around 90. Guys here. Now there's another way to read temperatures on this. This is a cool device. It has two little temperature statements here. The red one is the maximum temperature on the screen, and the green one is the minimum temperature on the screen. So I don't even have to, I just go like this and go, something on that screen is 106. And you can guess where it is. I'm going to make an adjustment on the colors here. So we're going to raise the temperature at which, oops, just select the right thing. Okay, I'm going to raise the temperature at which red starts. Way up. So now anything that's red is around 85 degrees. Let's go even higher. So I can't make that. It's 100 and something degrees. Again, you know what it is? I'm looking, I can see. I'm looking right through a hole in the chassis at the tube back here. So I'm getting all excited about nothing. No, I'm not looking at the tube now. Tube socket's getting up around 100 degrees. You know, things are upside down. The airflow is going the wrong way. Things are getting hotter than they were originally intended to get. Voltages. What am I doing here? Voltages. So, what are we determining? Voltages seem to be fine. We'll do the output tube now. The output tube usually has a higher plate voltage. Yeah, 245. They try to give it everything, because this is the guy who's doing the work. So he needs all the help he can get, including high plate voltage. 245, basically same voltage AM and FM. And that's on pin number 8987. Pin number 7 of this tube here. Pin number 7, we're on a 500 volt scale. So that'd be 9, 8. Wait a minute, the 7 doesn't appear to be hooked up. Oh, I'm counting them wrong. 9, 8. Well, 7 has the leaking, drooping, goopy capacitor on it. The goopy capacitor. Pretty hard to get the lead down there. Okay, we're going in. Going in. Is my hand in front of the meter? No. I gotta push wires inside there. There we are. Okay, so it's just about straight up. That's 230, 240. Something like that, and it's calling for right around there, 240, normal. And there is a screen. We'll take a look at that. It's very important. G2 pin 9. This is the screen. The screen has that big high wattage resistor on it. Ooh, don't touch it, man. This guy here. And slightly higher voltage. That's somewhat unusual, but it happens. A slightly higher voltage, 234. They show it slightly lower. Is that a concern? I doubt it. The change in voltage between AM and FM is because in FM, a slightly higher load is placed on the power supply, and all the voltages just come down a little bit because of that. Well, that's all that is. So we seem to be in good shape here. There's nothing dramatically wrong. Now if you look on the EL84, you'll see this. This is the grid bias voltage right on the what? Right. It has cathode bias. Right. So it has a cathode bias resistor, and it's making the cathode, this part here, a little bit positive. If this becomes a little bit positive, the grid looks a little bit negative. That's really what they're after, is the relative voltage of these two. So the grid is a bit negative relative to the cathode, so to make the cathode positive. So that's what they've done. That's very common. That's pin number 3. And it should be 6.9 volts. Okay, so we're on the 15 volt scale. 6.9 volts is going to be about here. About halfway, not quite halfway. And what was the pin number? Gotta get this one right. 3. Okay, so 1, 2, and 3. No, you're not counting them right. I think so. Oh, there appears to be, and I don't think this is 3. What am I doing wrong? Oh, there should be 3. There's a resistor on it. It looks like it's overheating. How would that be on a grid? Is this a grid? Okay, I'm watching what the meter's doing. It's going way over. We've got pretty high voltage there. 13 volts. 13 volts. And on the chart, it's calling for 7. Double the voltage. So what this indicates to me is the grid bias resistor. Cathode resistor has probably gone high, and I think that's the cathode resistor right there, the one that appears to be overheated and looks to be in kind of melted condition. I don't know why it would look like that. We'll take a closer look at that resistor, we'll measure it, and see what's up with that. Otherwise, voltages are not explaining any weakness in the operation of the radio, except we can't do the FM. Can't do the FM tube easily. The FM tube is just a triode, so all it's got coming to it is a plate voltage. It's a little hard to believe the plate voltage isn't there. I can pull the tube out and poke right into the socket. I can also put a tube extender on it and get out of that way with the tube in place, which is a better thing. Better to read these voltages with the tube in place because it's drawing current and affecting the voltages. Pull the tube out, voltages can go way high. That might hide a low voltage from you. Okay, those are the things to do next. Very good. Okay, let's investigate the resistor. I'm pretty sure it's the cathode resistor, and I've got the camera right here. Let's get a good close look at it, and what do we see? So, yeah, to me that's a damaged resistor. I'm pretty sure of that. I think this black cover should come right across. You can see how it's cracked right in here. And this looks like the wire that the resistor is made up of. You can see the wire through here. And you can see writing here that disappears as if it should continue across. There's the omega symbol there, and the ohms are written. Well, they're gone. So what this tells me is this resistor has overheated. Now it's a wire wound resistor. They generally don't go off. I mean, there's no guarantee of anything, but generally they don't go off. We have high bias voltage on this tube. That's going to get there only through a couple of ways. One is the tube is conducting way too much current, and that's setting up a larger voltage drop on this resistor. That's not likely. What's more likely is the resistor's gone defective, its resistance has gone up, maybe even doubled, and that's generating the higher voltage drop and the higher bias. So let's look on the schematic and find out what is going on with this resistor. Okay, so on the schematic, and this is related to the output, that's it right there. 170 ohm resistor right here. Half watt, 170 ohms. And then there's a capacitor right across it, the bypass capacitor. This probably needs to be replaced, but we can't be sure about that. 50 microfarads, that's a large amount of capacity to bypass a resistor like that, 170 ohms. Okay, let's read it and see what it is. Just get my millimeter here. We can read this. I mean, the radio's switched off, so I mean we can read it without taking it out of the circuit. Here. 170, eh? Okay, I'm taking bets now. Ooh, bets it's 170. Ooh, bets it's way over that. Putting the meter in an awkward spot. There we go. My guess? Okay, my guess would be 250. 170. So it hasn't gone high. It's where it should be. So the other explanation then is too much current. Well, there's a couple explanations. Too much current through the tube. That could happen because of problems in the, let's see, another resistor here to read, in the screen. It's a little hard to explain otherwise, at least for me. Unless this was an underrated resistor. They should have put a higher wattage resistor in there and they cheaped out. And unfortunately it didn't survive. Okay, now this other resistor, this is the screen resistor. It's pretty loose and wobbly in here. What do we get? We get 1.3. So 1300. Click back to the schematic. 1300 on the screen. Here's the screen. And whoa, there's no resistor there. Is that not the screen? Because it needs some wire. Yeah, I don't see how there can be a 1300 resistor. I've done something wrong. Okay, so I'm looking back in the radio. The terminal that big resistor is hooked up to is terminal number, well, it looks like terminal number 1. Looks like number 1. Of course, they don't number them here. Number 1. So we would find that the screen is number 1. What's happening here? So here. No, that's not 1. This is 1. This is 9. The screen is on 9. Something not adding up here. It's typical to have a screen resistor. There it is. It's way, they've just positioned it way over here. How does that work? Come off this terminal. So this and this can be one terminal. There can be, the terminal can be the terminal right up on the tube. So you'd see a connection straight to the resistor. 1300. That's exactly what we read. So it's okay too. We read the voltage here. It was okay. There's nothing pulling that down. We tested for the screen voltage here. It was a touch high, if I remember. It was just a little higher than that. Everything's okay. Maybe this needs to be changed out. I wouldn't rush at it now. Okay, so now we have another issue here, and that is this capacitor. So it's a very small one, 25 nanofarad. Very small. Let's see if we can find on the schematic what these symbols mean. The dots and the ears. Somewhere they may have a key on here explaining it to people like me. But I think it's probably a very standard notation in Germany. So why would they bother telling anybody? Look at this, it's got a dot and an open dot. 2 open dots, no tails. Tails and a, I don't know what that is, closed dot. I don't know what these dots are. Interesting. Two dots, 2 open dots, 1 single dot. I don't know, can't figure it out just looking at it. No doubt somebody's going to write a comment on the video, and that's great. In a situation like this where, you know, I'm looking at something, I don't know what it is. Sometimes I don't care to find out. I just don't think it's important enough. I just carry on. That's an opportunity for you as a viewer to throw a comment if you know what these things are. So other people watching the video, maybe they have this radio or one like it, and they're trying to learn stuff, and you can help them out by making comments about stuff that I'm not taking the time to delve into here. Especially if you're in Germany. This is probably all pretty straightforward stuff. Okay, so we found out everything seems to be fine voltage-wise in this radio. And we still have one more tube to test. That's right. We want to go. I'm going to put I called it a tube extender. It's really a socket extender. And then test the plate of this tube for 135 volts. Or a little more when it's in FM. Okay. Okay, I'm going to stop and get that set up. Okay, got my tube extender. Hopefully it'll fit. Now, this has the pin numbers written right on it. Let me just look myself. What is the pin number we're interested in? We are interested in pin number 1. So now we're looking down from the top, so it's the other. So that's 1. That's pin number 1. Easy to spot. Okay, pop this guy in. Will it fit? Yeah, right in. Okay. I'm not going to bother with the shield on it. It won't affect the kind of operation we're looking for. We're not trying to listen to this radio. We're just trying to test voltages. So practice session here. Where's my voltmeter lead? Where'd my voltmeter lead go? Here it is. Okay. Pin number 1 would be, of course it has to be way down here to do something like that to read it. Okay, I'm ready. Let her rip. I can slide this shield on, but unless the shield is grounded back to the chassis, it's actually worse. It'll be like putting a little antenna there. Okay, we're in medium wave. Can you hear it? Here's the volume difference when I put full voltage on. Not much. What is that? That's an airplane flying over my house. Wow! That was low. The whole house was pounding there. Whew, okay, enough of that. I survived. Now we'll go in. What are we expecting again? The voltage we're expecting here is 135 volts. So we're 150, so we're looking at it coming up in this area here on the meter. I always like to think that stuff out ahead of time. Oh. Okay, so we're not on FM right now. So we're going to go to FM. Oh. Okay, what's being done wrong here? What's being done wrong? There's nothing showing up. There's next to nothing there. Hey, there's absolutely 0. Something's not right. Something's not right. Okay, need to test another voltage. Somebody show me another. Now I've got the radio this way. Okay, so I can do it over here. Just to check the meter. This is the B plus voltage. Hey. Oh yeah, there it is. Meter's working. There's no voltage on this tube. Okay, checking again. Making sure it says pin 1. It does not. It says pin 9. This is pin 1. There we go. Okay, 150 volts on it, and what it's supposed to have is 135 or 174. It's in FM, that would be the 174, and if we put it to AM, it goes down a wee bit, still running up at 150. So it's a little high, but you know, that's just a little extra goodness, isn't it? So we don't have a voltage problem there either. That's good, because the components that are controlling the voltage on this tube plate are potentially hidden inside this welded, soldered down can. They never want you to go in. Power off. Okay, I'm going to put this back to the way it should be. See, when I was talking about tubes being sideways, here's one. Lives its life sideways. Get it right in there. Bingo. Put the sleeve back on. Okay, so why is the FM weak? Well, the next thing we're left with more component problems, hopefully not inside here. We can look at the signal strength coming out of this if we're lucky. It's probably coming out on this cable down here. Probably. There's another cable over here. And there could be terminals underneath that are coming through the chassis. This cable looks like it would probably be a shielded cable. Same with this one. Okay. This, of course, is the antenna input. We want to look at the output from here and find out if it's strong here and then getting weak as it goes through the rest of the radio. A little bit challenging, because what does a strong signal amount to here? So what I would like to try to do is find where the signal coming out of here exists in the radio. I could find it attached to the input of this tube and see what's there. And then judge whether what's there is what should be there, which is the tricky part. So an approach here would be put a tube extender on here and go after the grid after studying the schematic. Flip the radio over again and work underneath, which is maybe a little better because I can see what's is there any other wires coming out of here. Can I see that already? Yeah, so I'm looking down under this box. Just kind of got my head down there and looked down. You can see wires dropping out from in here. So what is what, I don't know. So I think flipping it over is going to be the best way to go about it. Okay, I'm going to stop here and just take a gander at how much video I shot. It's just getting towards lunchtime here. I usually like to stop before lunch, so let me check that out. So I'm pretty much at the 1 hour mark. I think I've had enough today. So we've done kind of the voltage check side of this and didn't really find anything too interesting. But we've eliminated that as a potential problem. That might have led me to some defective components. As you can see, I was testing resistors and that, but no, all seems good. The next phase is a bit of signal tracing, from what's coming out of the FM tuner and what's making it into the radio. How far is it making it and that kind of stuff. That's like another whole kind of thing as opposed to what I've been doing so far today. So I'm going to leave it for tomorrow and call it quits here today. Very good. It's very good. So thanks a lot for watching, and we'll see what happens tomorrow.